you should get 43. So these two angles are the same. 3x plus 14 equals 143. And you get 43. I think everybody who did that got it correct. So pat yourself on the back. That's fantastic. For this one, I was really surprised how many people, A, chose to do it, and B, got it right. This is fantastic. So angle PQS is this angle, and TSQ is this angle. They are not congruent, so that is not the right answer. I'm just going to get a different color. Then we come back here, PTR. So PTR is this angle. And then TPR is this angle. Those are also not congruent, so that can't work. So then we've got to come over here and mark these sides. So QS is this side, and PT, that looks okay. They could go together because they're the same. They're the left side of the big triangle and the left side of the right triangle. Then QR and SR, QR and SR, those are different sides. So this part of the proportion can't work. So then if we erase all of that because it just clutters up our lives, we can go check the last one. QR goes with PR. So that's the part and the hold, small and the big. So that works. And then SR and TR, and that works as well. So our answer is D. Just mark everything. It's not that hard. It's just a matter of marking, right? Questions on that? That was fantastic. I'm going to skip 3 for right now because 3 is a lot of work. So I'm going to skip 3. Remind me to go back to it. Question number 4 is going to be the part divided by the total. So the part is this balcony, which means that's 70 degrees. So 70 degrees divided by the total of 360. Remember the 360 always goes in the bottom. And then we need the length of railing. So length is circumference. So that's times 2 pi, and then the radius is 40. You put all that into the calculator, and I think you get 49. Is that correct? Anybody get 49? Okay. Question number 5 is exactly the same thing. Oops. With one tiny exception. Here, we're looking for the area. So we still start with the angle. Remember, central angles are the same inside and out. So 130 degrees divided by 360 times the area, which is pi r squared. So 5 squared. Put all of that in the calculator, and I want to say you get 28. Was that the correct answer? I'm not hearing anybody today. I'm wondering if my speakers are on.
Wait, can you explain that real quick? Because I guess it's completely different.
Absolutely. Yeah, and maybe I did something crazy. So the closest angle or the closest area to the shaded sector, because it says shaded, we want this part, the 130. So 130 over 360. And then it says the area. So we need to use the area formula, which is pi r squared. The last time we wanted the length of the railing, so we used circumference 2 pi r. So let me double check in my calculator and make sure I didn't do anything crazy. 130 divided by 360 times 3.14 times 5 squared, which is 25, is 28.34.
Okay, yeah, I did it again, and that's what I got.
Okay. Sometimes we just do something weird in the calculator. 11, for whatever reason, is the most popular wrong answer. And I wonder whether that's 2 pi r. So 130 divided by 360 times 2 times pi times 5. Yeah, if you got 11, you use circumference instead of area. Does that make sense? All right. Question number 6, you just needed to remember the relationship between the equation and the circle center. Remember that this is H and this is K, but the formula has them being subtracted. So this is going to be a -4 and a +5. The circle center and the equation are opposite signs. So if I have +4 and -5 in the equation, I need -4 and +5. Guys, you have Desmos, right? I love that I saw people graphing it not only like this, but then also they put another point on the circle and then sketched the circle. That was fantastic. Loved it. Okay, when in doubt, just put that whole thing in Desmos. It'll give you a visual. Question number, oh, that's the same. Question number 8 is exactly like the balcony question and the circle question with the area for 130 degrees. This time, though, we're just not given the whole circle. This is one little part of a much bigger circle, okay? So all we care about is this little piece of the arc. We just don't see the rest of the circle, and that's what makes this one hard. The design for an arc-shaped stand of a hammock was shown as 144 degrees. So 144 degrees is the piece that we can see, with a radius of 2.3 meters. So 2.3 is the radius. If you're given an arc with an angle and a radius, put that bad boy into the part divided by 360 times, and then I'm looking for length. So if I'm looking for length, do I want circumference or do I want area? Circumference, absolutely. Length is always circumference. Area is always area. So 2 pi and then 2.3 meters. And then you just put all of that into the calculator. So grab a calculator, 144 divided by 360 times 2 times pi times 2.3. Do we get 5.78? This is the hard version of that sector area and arc length, because you're not immediately like clued into this formula that this is what you have to do. And again, guys, taking the SOL, this formula is not on the formula sheet. So you just have to kind of memorize it. That's why we're practicing it so much. All right, last question. We are not going to officially do any lessons on this kind of thing, but the very basic ones like this are pretty straightforward. You just need to learn a pattern. So if you've dozed off, stop paying attention for a moment, come back and join me for question number 8 and question number 3, okay? The ratio of the volumes of two spheres are 8 and 27, and this is volume. What exponent does volume have? Is it meters, meters squared, or meters cubed? What does volume have?
Cube.
Cube. So we've got length, we've got area, and we've got volume. And volume is cubed. Area is squared, and length is to a power of 1, right? So if my volume is 8 to 27, if I take the cube root of that, that'll take me back to length, right? So what is the cube root of 8? And at this point, I want to open Desmos up. Because it's not immediately obvious where the cube root is in Desmos. Okay. And I think I have to minimize this because the toolbar is like, it hangs out underneath my Screencastify. Oh, but it's not gonna move. Sorry, I thought I had done this earlier. Oh, darn it. It's still not going to work. Wonder if I can do this. Cube root. Nope. Doesn't work. All right. Hold on 1 second. I got to stop sharing. Oh, this is what I can do. All right. I'm going to get smart. Maybe not. There we go. All right. If you find your keyboard down here and you go to functions, I always have to, it takes me a minute. I think it's under miscellaneous. And do you see that N root right there? So open up Desmos, go to the keyboard, go to miscellaneous, and then go to this function right here. You want to put a 3 up in the top and then an 8 in here. So the cube root of 8 is 2. And then our other one was 27, right? So the cube root of 27 is 3. So if I go back to my warm-up here, and now that I've closed my